Welcome to Noble of Chemistry. Today we're going to start the topic is color of lanthanoids. So ரொம்ப colorful இருக்கும் இந்த topic. So that is most of the metal it is existing as the color in the lanthanoids. Say for example it is lanthanum, cerium, it is in the white color in the solid state, and it is neodymium, it is orange color in the solid state, and promethium it is yellow color in the solid state, and presode it is a green color in the solid state. These and all. Suppose some of the metal it is in a solid state, it is existing as a color, as well as in some of the metal it is existing as a and in color in a solution state. So look at here, it is thulium, it is in the liquid state, it is in the color. So now let us see how the color it is formed. So we see one by one. See, already we are completed in the previous chapter. It is how color it is formed in the D block elements, how the D block elements are, it is making a color. Okay, because due to the transitions. What a transition? And say, for example, it is the D block element. Okay, that will be split up into two energy level. One, it is a lower energy level, which is dxy, dxz, dyz. Other one, it is a higher energy level, dx square minus y square and dz square. Okay, so now so only one electron in this dxy orbital in the ground state energy level, that electron, it is observing the electromagnetic radiations from the sunlight. Okay, so that is existing at the visible region. Exactly, it is observing the electromagnetic radiation, visible region radiation it is observed. That visible region radiation, it is 400 to 800 nanometer wavelength range. That is wavelength range of this visible region, it is 400 to 800 nanometer wavelength range. So it absorbs this among these 400 to 800 nanometer range. Okay, so among these range, it is absorb only any one range, one radiation, because it is in this range only, it is a WIBGR. WIBGR. That is meaning of violet, indigo, blue, green, yellow, orange, red. WIBGR. So among it is absorbing any one of this color radiation, color wavelength, it is moved on to the excited state level. Look at here. It's moved on to the excited state energy level. So now that excited state energy level, that is a transition, it is called as a DD transition. Upper electron transfer in the lower energy level to higher energy level state, that we called as a DD transition. DD transition. Okay, that excited state energy level not be the very stabilized. Okay, so that it is emitting the complementary color. What it is color? It absorbed not exactly equal color. It is emitting the complementary color. Okay, it is emitting the complementary color. It is again comes to the ground state, because excited state not be the stable. Because excited state, because higher energy level. Okay, we know that is energy which is inversely proportional to stability. Energy which is inversely proportional to stability. Those elements having a greater energy, that will be the lesser stability. Okay, so that they having a greater higher energy level, stability will be lower. So higher energy level stability. So it wants to attain the again stability. So it is again comes to the ground state energy level. So that stability will be very higher. Stability is very higher. Like this, F of transition also will be takes place. Now we let us see F of transition. So in this F orbital, that's we representing, it is F x cube, F y cube, then F z cube, then F x y z, then this one F x into y square minus z square, then this one F into y into z square minus x square, and this orbital we referred as z into x square minus y square. That is also split up into two energy level. One, it is a lower energy level. Okay, that four energy levels are lower energy level. Okay, and remaining three are, it is a higher energy level. So electron moving from the f orbital into into lower energy level orbital into higher energy level orbital. That is we called as a F transition. That's we called as F of transition. F of transition. Okay. So now that one electron and lower energy level unpaired electron, it observing the electromagnetic radiation from the visible region. So that we know very well. That is a visible region or a wavelength in the range of 400 to 800 nanometer. Okay. It is moved on to the excited state level. So look at here again, I show you. Okay. So this ground state energy level electron, that is observing, after observing the incident light or electromagnetic radiation in the visible region, electron transferring from the ground state, I mean lower energy level into excited state energy level, higher energy level. So that will be emitting the radiation, emitting the complementary color. Okay, that it is emitting the complementary color. What it is observed, it is emitting the complementary color. Again, it is comes to the original state. Again, it comes to the original level. Okay, upon this transition, it is called as a F of transition. So that the element, F block elements also, it is a color, it is existing. What is important note? Kindly note the children, what it is an important note. So it contains at least one unpaired electron. Okay. So it contains at least one unpaired electron. Okay. More than one, it is okay. At least one unpaired electron, because due to the transition, electron traveling from the lower energy level to higher energy level, then only it is will be the compound, it is get color. Okay, at least it contains one unpaired electron, then only the compound it is existing the color. Okay, so this is the reason the compound it is existing the color. I will show an example. Now let us see the examples. Okay, then we know very well the lanthanum and atomic number it is 57. So 4f0 5d1 6s. Suppose I used as a lanthanum 3 plus ion. Look at here. After it is losing 3 electrons. So 2 electron lost from the s orbital, 1 electron lost from the d orbital. So it become lanthanum 3 place. So it become 4f0. No electron in the f orbital. No electron in the f orbital. So it is the colorless. Because no possible transition, it is not possible in this case. Because at least it is required one unpaired electron. Not even get that one unpaired electron. How it is a transition, it is possible, children? No. Transition, it is not possible. So that the compound, it is existing as a colorless. Okay, colorless. Okay, so that it is the upper compound containing F0 system. Say for example, in your cerium 3,4 plus also, the configuration as 4f1 5d1 6 is, sorry, 4f0. Configuration of that cerium 4 plus, no? Upper 4f0, 4f0. Upper 4f0, no, that is also no color. 4f0, no color at all. Okay, because no electron, no unpaired electron, so no color. Say for example, another example, it is lutetium, completely filled configuration. It requires completely filled. Lutetium 3 plus also completely filled F orbital. Completely filled F orbital. So look at here. I showing you. Okay, this is the but no unpaired electron it is available. So electron also filling is a lower energy level as well as higher energy level. Upon no unpaired electron it is possible. No transition it is for no vacancy at all. All the place it is completely filled. No vacancy. So no unpaired electron. So this is also not possibility existing as a color. Okay, so that the element it is containing F14 system also it will be colorless. Okay, it's a colorless. F0 system as well as F14 system also it has become very colorless. Okay, that is very important note point. Okay, they are asking in the 1 mark point of view. Okay, it's kindly note it down this point. It is very important. Next, let us see what about the remaining elements. What about the remaining elements? Color, whether how the color it is formed. Praseodymium. It is 4f3. 4f3. Okay. Praseodymium 3 plus abina 4f2. Okay, because 2 electron losing from this 2 electron from s orbital and 1 electron from the f orbital, so it become 3 place. 4f12, sorry, 4f2. But it contains two unpaired electron. Thulium also, it contains two unpaired. I will show you how it will be. Okay, thulium also two unpaired electron. Look at thulium 3 place. So it also contains two unpaired electron, children. Okay, here also look at here two unpaired electron. Upon both the case, it is contained two unpaired electron. This is also, it is two unpaired electron. And your praseodymium also containing two unpaired electron. Both are having two unpaired electrons. So, if it is the same number of unpaired electron, that is very important note. The element or ion, it contains same number of element or ion contains same number of unpaired electron, same number of unpaired electron that will produce same color. Let us see in the praseodymium and the thulium what color it will produce. Right. So that is both containing, it is the two unpaired. Praseodymium also, thulium also, it containing two unpaired. I just mentioning only unpaired electron. That will be ground state level. Okay, that it is observing the radiation, it is move on to the excited state level and it is producing the color. Okay, so it is producing the green color. Both praseodymium 3 place as well as thulium 3 place, both it will be producing green color. Okay, this is the color of the compound. Next, we will check it is the rest of the element. Eppadi irukku check panikalam parunga. This one tabulation it is there and that will be colorless because 4 of 0 colorless. Cerium 3 plus 4 of 1 colorless. 4 of 1, sorry. So here it is. And cerium 4 place 4 of 0 colorless. Then praseodymium 4 of 2 green color. Neodymium 4 of 3 red color. Promethium a pink color. Samarium 3 place yellow color. Okay, so like this pink color. Gadolinium, it is the colorless because 4 of 7 also it is not the existing color, that is also colorless. The same color, this element, I will show you one second once. Right. So how these two elements have the same color? Then your praseodymium and thulium both have the same color because both containing two unpaired electrons. Okay. Then in case of your terbium, it is 4 of 8. Look at here. 4 of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now tell me how many electron has an unpaired electron? There are 6 unpaired electron. 6 unpaired. But this element also it containing 6 unpaired electron. 6 unpaired electron. So it would be existing pink color. But this element, it is 4 of 9. So 1, 2, 3, 4, 5, 6, 7, 8 electron, 9th electron. So remaining how many electrons? So 1, 2, 3, 4, 5. Okay, there are 5 unpaired electron. Okay, 5 unpaired electron. This is samarium 3 plus also 5 unpaired electron. Okay, both having same number of unpaired electrons, so it is producing the same color. Okay, this is also, it is a 4 of 4 and this is also containing, it is like this 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10. Okay, that is the 4 of 4 unpaired electron. This is the one, yes, both having the same number of unpaired electrons, so it producing the same color. Okay, this is the simplest way. Another simplest way is also there, and we find out in this. So, every calculate this. The total number of electron. If thulium and praseodymium renduna same color are another methods at also. It is 14 minus So inge prosodium 2 electron minus 2 which is equal to 12. Upper 4f12 இருக்கிற system 4f12 look at here 4f12. So both having the same color. Another method, listen me children. இங்க பாருங்க total number of electron 14. இப்ப நியோடைமியம்க்கு செக் பண்ணலாம், நியோடைமியம்க்கு எர்பியம்க்கு செக் பண்ணலாம். And நியோடைமியம் total 14 electron in f orbital, நியோடைமியம்ல 3 இருக்கு. Okay, so that it is become, it is 11. So 4f11 configuration, it is existing as a same color. Okay, then praseodymium, okay, sorry, promethium 14 minus 4, it become 10 electron. So that's 10 electron. Okay, like this we can easy to find. Suppose we can't able to identify means, so like this we can easily identify which configuration f orbital enna electrons, number of electrons irukko, that will be existing as a same color, that is existing as a same color of the compound. Okay, next one parunga. See the basement problem. Why do we see color in the F block elements? Okay, the answer it is A and C. Look at here. In the first one, it is the reason it is F of transition, and the other one it is electron moving from the lower energy level to higher energy level. So that option A as well as option C. Then out of the following, which is the colored? So praseodymium. Okay, this is 4F. Okay, this compound and idellame F0 and F7 configuration. F0 and F7 configuration. So it is that and colorless. Yes. What is the color of lanthanum 3 place? It is colorless. How many orbitals do we have in F subcell? It is F subcell, they are having 7 orbitals. Which is the colorless? Colorless. They are asking colorless. Cerium 3 plus as a colorless. Okay.